Hi, I am H.W. Dong. This is the fourth lecture of my Python tutorial. In this lecture, I will talk about operators in Python. In Python, there are many different kinds of operators, and we will talk about these different kinds of operators. If you are interested in my video, you can subscribe my YouTube channel HWDNG. Okay, let's start our class. Operators are used to perform operations on data objects, such as variable and values. Python has different kinds of operators. The first familiar operators to us are arithmetic operators, and their operators assignment operators and comparison logical identity membership bitwise operators. Arithmetic operators are used to do arithmetic computation. These operators are very familiar to us. For example, add operation used to add two operators, and sub operation used to subtract one operator to another operator. We should focus on the module. Module is used to find the remainder of division of two integers. And this operator is called floor division. It is used to do integer division. And this division is used to divide in two operators in float. Let's see an example. For example, x and y is this. We can use plus or addition and the subtract to do. And this operator can also use it for one operator. It means the usually plus. This operator can use for one operator. It means usually minus. For example, in this is plus x. This is negative x. This operator is used to divide two operator in float, and this is used to divide two operator in integer. We can see the result: x plus y, x sub y, plus x sub negative x, and x multiply y, x divided y in float, x divided y in integer. And this operator is a power operator, also called exponent operator. It is used to compute the power. It is used to compute the x power of y. Another kind of operators is often used is comparison operators. Comparison operators are used to compare values. It returns either true or false condition according to the compare result, compare condition. This to test if two values are equal. If two operators are equal in value, this is to test if they are not equal. This is greater than. These comparison operators are easy to understand. Let's see the result. X, Y is this, and X larger than Y is true. X less than Y is false. X equal to Y is false. X not equal to Y is true. X larger than, X greater than or equal to is true. Logical operators are used. There are three logical operators: not, or, and. Not. Before we talk about the three logical operators, I should talk about long. This is a keyword. The keyword long is used to define a null value, or the value, or no value at all. Null means no value at all. For the not logical operator, not x means if x is false or 0 or none, then the result is true. Otherwise, the result is false. For example, not false, 0, none. Their result is true. Not true, non-zero, non-nine. Their result is false. The second logical operator is OR. OR is a binary operator. X or Y means if X is not none, or X is true, or X is not 0, then the result is X. If X is none, or X is false, or X is 0, then the result of X or Y is Y. Let's see the example. X is false. If X is false, then the result is Y. X is false, the result is Y. X is true, then result is X. Result is X. X is true, X is true, X is true, then the result is X. For this, because the X is true, non-zero, true non-zero. X or Y, the result is X. For this, because X is false or 0 or none, then the result is Y. X is none, so the X or Y, the result is Y. And is another logical operator. X is also a binary operator. X and Y means if X is none or 0 or false, then the result is Y. If X is false, none, 0, then the result is Y. Otherwise, the result is x. For example, x is false 0, so the result is the result is x. The result is x. If x is non-zero or false, the result is x. X is false, non-zero. So x or y, the result is x. If otherwise, if x is not long, not zero or true, the result is y. For this, the result is y. The result is y. These are logical operators. Let's see the bitwise operators. Where every data is represented in computer in binary digits. For example, the integer 2 can be represented in binary digit 1 0 in binary, and 7 is this 3 binary 1. We can use the format method of string to see the binary digits of an operator. For example, x equal to x is a value of the object 37. Then we use this format to format a in binary digits. Then the a is binary digits is this, and bitwise operator are operated on bit operators act on operands as if they were string or binary digit. There are six bitwise operators. We first see these 3 bitwise operators. X and y is called a bitwise AND. This operator do AND operation for each bit of the operands. Let's see the example. We first print out AB in binary digit. Then we do operate bitwise AND and bitwise OR. This is bitwise OR. This is bitwise exclusive OR or XOR. We can see A, B is this kind. For bitwise AND, it do operation for the corresponding bit of the 2 operand, because this bit is 1 and this bit is 0. So a bitwise and the result is 0 because 1 0 and the result is 0. The bitwise AND, when all the bits are 1, then the result is 1. Otherwise, the result is 0. For example, this and this, the result is 0. A bitwise OR is different when one of the two bit is 1, then the result is 1. For example, this is 1, this 0, and the result is 1. This is 0, this is 1, and the result is 1. Only when the two bits are all 0, then the result is 0. Otherwise, the result is 1. Bitwise XOR, when the two bit is different, then the result is 1. Otherwise, the result is 0. For example, this is 1, this is 0, so the result is 1. This is 0, this is 1, so the result is 1. These and these are all 1. They are same, so the result is 0. These are all 0, so the result is also 0. This bitwise operation is called complement of x. It returns a number by switch 1 to 0 and 0 to 1, except for the highest bit. This operator's result is negative x sub 1. For example, A is this, and complement of x is this. This operator is called left shift. Left shift. It returns x with bits shifted to left by y places, and the new bits on the right side are 0. This is same as multiple x by this. And this operator is called shift right. It shifts bits to the right by y places. This is same as this operation. The integer division by x by 2 power of y power of 2. You can see this example. B is a binary form is this, and B left shift 2. It means this left shift 2 bit. So this will move to this, and this is moved out, and the left is filled with 0. This operation is shift right, so this will shift right to this will shift right to this, and the left filled with 0. The bitwise operator is seldom used in our general program. Another kind of operator is assignment operators. The simplest assignment is a equal to 5. This is mean we define a new variable a. This variable is referred to the object 5. If we write again another command a equal to 7, this means we define a new variable a referring to the object 7. For example, a equal to 5. We print the ID of the a, that is ID of 5. Then we let a equal to 7. This means we define a new variable a. This a and this a are two different variables. First, the name a as a variable refer to the object 5. Then a as a new variable refer to the object 7. So the ID will be different. We can see from this. The simplest assignment can combine with arithmetic and bitwise operators. For example, a plus equal 5. This is equal to a plus 5. But there has different mean. This a, for example, first a equal is a variable of integer 3. Then when we do this operator, a is a new variable. This variable refers to the new object. The new object is a result of a plus 5. So this a and this a are different. We can print b equal to a means a and b refer to the same object 3. So when we print ID b, the result should be same as this because a and b first refer to the object 3. But when we do this assignment, a is a new variable refer to the new object. So this ID will be different from this. And this operation is equal to this operation. So this a will different from to the previous a. You can see first a ID of a, then b ID of b will be same as a, but this a will be different from the previous a because a is changed to refer to a new object. Assign operator equal can be combined with algorithm operators and bitwise operators as this table. For example, a divided equal to 3 is equal to a equal to x equal to x divided 3. There are some special operators. One special operator is identity operators. There are two operators, is and is not. Identity operators to test if two objects are the same object. For example, a, b refer to the same object 5. to the object 5, we can test if they are same or if they are not same. X and Y leave to X leave to this string, Y leave to string. We can test if X is Y, if X and Y leave to the same object. AB equal to A is the name of the list, B is the name of this list. We can check if A, B is the same. For this, we can see AB is same, AB is same. So A is not B is false. And X is Y is same, means X and Y leave to the same object. So X is not Y is false. But for this, AB is false, so AB will not leave to the same object. So A is not B is true. Another special operators are membership operators. The membership operators are in and not in. They are used to test whether an object is found in a sequence. The sequence can be string, list tuple, set, and dictionary. For example, X is a leaf to the string. We can check if the string H in X in the object X leaf to. We can see check if hello in. We can check these print or false. A lot in is true because this string is not in, but this in is true because dong is in the this is not is false is true this is true. We can see another example. Y is a dictor. We can use these to test if one is a key in Y. One is a key in Y, so this will be true. And this string, if this string in Y, because this is not the key of Y, so this result will be false. We talk about all these operators in Python. We talk another topic, operator precedence. Operators have different precedence. Operator precedence affects how an expression is evaluated. For example, 3 plus 5 multi 2. For this expression, there are two operators, plus and multiply operator. Because operator has high precedence than the plus, so first this operator is computed, and then the result will be added with 3. So the result is 13. We can see different operators precedence on the internet. I can this. The precedence has the highest precedence, and the or and has low low precedence. But we need not to remember operator precedence. We need not to remember the table. You can use precedence to change the order for computation because these operators has a highest precedence. For example, we can use precedence to do first add operation and then sub operation, and the result will be divided. So these and these will be computed first, and then do this operation divided. Okay, this is the end of the lecture. We talk about different kinds of operators, and we also talk about the operator precedence. Also special operators and operator precedence. Thank you for watching my video.